మీదైతే దానిని అందించడమే విమ్స్ లక్ష్యం.
Good evening children, welcome to WIMS Institute app. My name is Rajesh and I deal with physics for your upcoming Polycet exams. So without wasting our time, so let us try to understand about the first concept in physics, that is called as what? Heat. So most of the children of 10th standard know what is heat actually. In our lower classes or in 10th standard we might have studied that heat is a form of energy. So fine, heat is a form of energy. It flows from hot bodies to cold bodies. It flows from hot bodies to cold bodies. So directly we will enter into a concept where we will try to understand about is there any mathematical formula to find out how much heat is lost by any object or how much heat is gained by any object. Because already we might have known that heat lost by hot bodies will be always equal to heat gained by cold body. So is there any mathematical formula or is heat is a measurable quantity? Yes, heat is a measurable quantity which can be measured. So how to measure heat? So for that we apply a mathematical formula to measure quantity of heat lost or gained by using a formula Q is equal to ms delta T. So this is a mathematical formula in 10th standard. The derivation of this formula is also there, but right now since we are going for a competitive exam, we need to know its application without undergoing its derivation. So Q is equal to ms delta T will be the mathematical formula for calculating heat lost or heat gain, where Q stands for quantity of heat, M stands for mass of the substance, the substance what you have taken, S stands for specific heat of that substance. So about specific heat we will have a class in detail, and delta T stands for difference in the temperature. That means before heating any object or before losing, what is the initial temperature of that object and what is the final temperature of that object, that is called as delta T. So delta T represents difference in temperature. So by this particular formula we can able to find out heat lost or heat gain. So that means heat is a measurable quantity. So fine, heat is a measurable quantity, sir, but in physics measurable quantities needed certain units. So let us see what are the units of heat in CGS system as well as in SI system. In CGS, heat lost or heat gain can be measured by using a unit called as calories. Short form is cal. In SI system, the quantity of heat is measured in what? Joule. So this is calorie, this is joule. These are the units used for measuring quantity of heat lost or heat gain. All the physical quantities in physics should be expressed in CGS as well as in SI, and we should also know the relationship between calories and joule. So let us see what is the relationship between calorie and joule. 1 cal can be written as 4.186 joule. But sometimes to make our numericals easy, in spite of taking 4.186 joules, we can also take 1 cal, approximately 4.2 joule. 4.2 joule. So that relation everyone need to understand very clearly, that 1 calorie is how many joules? 1 calorie will be 4.2 joules. So in Polycet exam, some numericals will be also asked between these two relations. So let us see one example how the numericals are going to be asked in this basic relationship. So already we know that 1 calorie will be 4. Actually it is exactly 4.186, but approximately we'll take it as a 4.2 joule. So the problem will be asked in this way. 5 calories is how many joule? 5 calories will be how many joules? So simply what are you going to do? You just multiply 5 calories means 5 into 4.2, that gives you 21 joule. Is that clear? 5 calories, it's just like a unitary method. One chocolate costs 2 rupees, 5 chocolates cost how much? In the same way, 1 calorie is going to 1 calorie approximate value is 4.2 joules. 5 calorie is how many joules? Sometimes it might be also asked in a reverse way. 21 joule is how many calories? So quite reverse. If you convert calories into joule, you need to multiply. If you want to convert joule into calories, you need to divide. So 21 joule, approximately it comes 5 calories. So 21 divided by 4.2. 21 divided by 4.2. So numerator and denominator should be multiplied with 10 to remove the decimals. So that gives you 210 by 42. Is that clear? 210 by 40. So approximately when you do this calculation, your answer will be 5 calories. So like this, the numericals might be asked in your Polycet exams for in MCQs. The numericals is based on calories and joules, so you should know that relationship. So this is about something called as heat. So we learned about what is heat. Heat is a form of energy which flows always from hot bodies to cold bodies. To measure heat, a mathematical formula will be Q is equal to ms delta T. We'll study what is S stands for particularly specific heat of the substance. Now let us enter into next topic, where we'll try to understand about temperature. What is temperature actually? Is there any relationship between heat and temperature? Is temperature is also a form of energy or something else? See children, temperature is quite different when compared with heat. Temperature is just a type of measurement. Measurement in a sense, if you want to decide whether the body is hot or cold. If it is hot, how much hot is that? If it is cold, how much cold is that? So that is called as temperature. So basically in a simple words, if I want to say what is a temperature, it is just a measurement of hotness or coldness of a body. It is just a measurement of hotness or coldness of a body. So temperature is defined as measurement of hotness or coldness of a body. Its work is only measuring. In a sense, if suppose I am having a cold water, I want to know how much cold is that. If suppose I am having a warm water, how much warm is that. So I can't say by touching. Properly I need to measure its temperature. So that is called as what? Temperature. So anything measuring hotness or coldness of any object, it is called as what? Temperature. So particularly for measuring temperature, we have different scales also. So let us see what are the different scales to measure temperature. So generally temperature is measured in 3 scales: Celsius, Kelvin. We also have one more one more unit for measuring temperature. So we call it as a Fahrenheit. Temperature can be measured in three scales, actually four scales. When you go, particularly even we also have Reaumur scale. So that is not particularly required now. So generally we can measure in 10th standard we have measurement of temperature in two scales, Celsius as well as Kelvin. But we also have in 7th standard or 8th standard, when you go, we also measure temperature in one more scale, which is called as Fahrenheit scale. So these are the different scales for measuring temperature. It can be measured either in Celsius scale, or it can be measured either in Kelvin scale, or it can be also measured in Fahrenheit scale, or it can also be measured in one more scale that is called as Reaumur scale. So we won't require Reaumur scale right now. We need to keep concentration on Celsius as well as Kelvin. When you talk about Celsius scale, particularly temperature, again as I told you, temperature is also a measurable physical quantity. It is also a measurable physical quantity like heat, but the difference is that temperature is a measurement, heat is a form of energy. So if you want to measure temperature in Celsius scale, that is in CGS we measure temperature in Celsius scale, and in SI we measure temperature in Kelvin scale. So in 10th standard we also have a conversion, Celsius to Kelvin or Kelvin to Celsius. So there is a small trick how to convert Celsius to Kelvin. If you want to convert temperature from Celsius scale to Kelvin scale, dear children, directly you can add plus 273. Plus 273. If you want to convert temperature from Kelvin scale to Celsius scale, what are you going to do? Simply you just write minus 273. That is the basic logic or a small trick. In spite of reading or by hearting the formula, you can directly convert temperature from Kelvin to Celsius or Celsius to Kelvin. Please remember this cycle. If the temperature is given in Celsius, if you want to convert it into a Kelvin, what you are going to do? You need to add plus 273, and when you convert temperature from Kelvin to Celsius, what you are going to do? Minus 273. Let us take one example. For example, if I say the boiling point of water is 100 degrees Celsius, then what is the boiling point of water in Kelvin scale? So simple logic, by seeing this graph we can able to say 100 degrees Celsius, the temperature has been given to us in Celsius, we are going to convert that one in Kelvin. So what you are going to do? You just add plus 273, then your answer will be 373 Kelvin. Is that clear? It might also ask, if temperature is given in Kelvin scale, you want to convert it into Celsius scale, what are you going to do? Let us take that example only. The question might be asked, if the temperature in Kelvin scale is 373 Kelvin, what is the temperature in Celsius scale? You just see that graph, it will be minus 273. So if it is minus 273, automatically it will be how much? 273 plus 100, 373, 373 minus 273, that gives you how much? 100 degrees Celsius. I hope the things are very clear. From Celsius to Kelvin, how do we convert? And from Kelvin to Celsius, how do we convert? So we also have temperature in one more scale. What is that scale? Fahrenheit scale. So let us see that relation also. What is the SI unit? What is the CGS unit to measure temperature? CGS unit will be always Celsius, and what is the SI unit for measuring temperature? That will be always Kelvin. Particularly if you measure temperature in Kelvin scale, you will get accurate temperature. That's the reason there is a one more important definition in our 10th standard. What is absolute temperature? Absolute temperature. Absolute temperature is nothing but if the temperature is measured in a Kelvin scale, that is called as absolute temperature. So maximum scientists all measures temperatures particularly in Kelvin scale in spite of using Fahrenheit, Reaumur or Celsius scale. So let us go ahead. Okay children, as we are discussing about that how to convert temperature from one scale to other scale, so you please remember this particular formula. where we can see conversion of Celsius to Fahrenheit, Fahrenheit to Kelvin. If in an exam the temperature has been given in Celsius and you are supposed to ask to find the temperature in Fahrenheit scale, you please follow this relation. This relation. Only you need to do, if suppose temperature is given in Celsius, in place of C you write the temperature and calculate F, which is a Fahrenheit scale. Sometimes what happens, if the temperature will be given in Fahrenheit scale, you substitute the value of F and calculate the value of C. So we will have numericals on that also. And if you want to convert temperature from Fahrenheit scale to Kelvin scale, so you please use this relation. So then you can easily convert temperature from Fahrenheit to Kelvin. And I already told you a small technique to convert Celsius to Kelvin or Kelvin to Celsius. If you want to convert temperature from Celsius to Kelvin, what are you going to do? Plus 273. And if you want to convert temperature from Kelvin to Celsius, you directly do minus 273 without using these formulas. You can do that one. So I hope everything is clear related temperature. What is temperature actually? A temperature is a measurement of hotness or coldness of a body. Temperature can be measured in 3 scales, generally 4 scales. But as per our point of view, we need to follow 3 scales: Celsius, Fahrenheit and Kelvin. What is absolute temperature? Absolute temperature is nothing but if the temperature is measured in Kelvin scale, that is called as absolute temperature. So by this we completed the concept of temperature. So let us move forward with another concept. Let us talk something about thermal equilibrium. Thermal equilibrium. What is this thermal equilibrium? If I say, suppose I have taken 2 bodies, hot and cold. I brought them very close to each other. This is my object A. This is my object B. A is hot. How can you say that A is hot? Let us say the temperature of A is some 30 degrees Celsius and temperature of B is, let us say, some 25 degrees Celsius. So obviously A is a hot body, B is a cold body. So both are in contact. So automatically there is a transformation of heat. That is only the definition of heat. Heat is a form of energy which flow from hot bodies to cold bodies. So from where to where heat starts flowing, or from where to where, what is the direction of the heat? So if you want to know the direction of heat, obviously you need to see what is the hotter object. The hotter object is A. So heat starts flowing from A to B. This will be the direction of heat. Now if I say, sir, how long this transmission takes place? Does the heat will transfer for the whole day or for the whole night? No. The process of transmission of heat will be taking place for some period of time. For some period of time. It does not take place for a long time. Generally what happens, A is losing heat, B is gaining heat. So automatically the temperature of A will be reduced. The temperature of B will be increased. So there is one situation, you will come one condition where the temperature of these 2 bodies will become equal. At that particular period of time, generally what happens? When the temperature of both bodies, becomes equal, at that particular condition, the transmission of heat is going to stop. Now what do we call this condition as? Which condition, sir? When the temperature of body A becomes equal to temperature of body B, that condition is known as thermal equilibrium. So what is thermal equilibrium actually? Thermal equilibrium is a condition, thermal equilibrium is a stage, thermal equilibrium is a scenario where the transmission of heat stops. Or when two bodies acquire same temperature, at that particular period of time, there is no further transmission of heat takes place. Then we can say that A and B have acquired thermal equilibrium. So there is a small concept of thermal equilibrium. In exam it might be asked, if A is at 45 degrees Celsius, B is at 30 degrees Celsius, from which body to which body transmission of heat takes place? Obviously the body which is at high temperature, that is called as hot body, and the body which is at low temperature, that is called as cold body. So this is a small concept of thermal equilibrium. Let us proceed forward with one more concept in this lesson, that is called as relation between temperature and kinetic energy. We'll study the relation between temperature and kinetic energy. So what is this relation between temperature and kinetic energy? I need to understand what is the relationship between temperature and kinetic energy. So let us do one small example, or let us do one small activity for that. Let us take a beaker. Let us take a beaker which contains water. Sorry. Let us take a beaker which contains water. Generally, you know that in water we have water molecules, particles. These are water molecules which are moving in random directions. Since it is a liquid, in liquid water molecules does not remains in it is not a solid. If it is a solid, the molecules are fixed. But now this is a liquid. Since water is a liquid, so inside the liquid the water molecules keeps on moving from one place to another place. In physics, any object which is under motion, whether it is a big object, whether it is a small object, it has kinetic energy if it is in motion. If it is in motion, the board is at rest, kinetic energy is zero. Water molecules are in motion, so obviously they have certain kinetic energy in them. What is kinetic energy? In 9th standard physics it will come. Kinetic energy is nothing but the energy what is possessed if a body is under motion. The energy possessed by a body if the body is in motion. Example, a moving fan is having a kinetic energy, moving ball is having a kinetic energy, moving water molecules also have a kinetic energy. So what is my concept? I need to understand the relationship between kinetic energy of the molecules and temperature. That is my concept. What is my concept? To understand the relationship between temperature and kinetic energy. So let us, what we are going to do now, this beaker, let us start heating. Keep this beaker on a flame. So automatically what happens? Heat will be transferred. You keep thermometer, laboratory thermometer here. Automatically what is going to be happen? The temperature of this water increases. When the temperature of this water increases, what about these molecules? These molecules again move faster and faster. Why, sir? Because they are getting energy. Heat is a form of energy. These molecules receives that energy. Initially they used to move little slowly, but right now they start moving very fast, faster and faster. So it means kinetic energy of the molecules is directly proportional to temperature. Physics or maths depends upon two relationships: direct relationship or indirect relation or inverse relationship we call. So here what is the relation between kinetic energy and temperature? Kinetic energy of the water molecules are directly proportional to absolute temperature. So that we need to understand from this concept what is the relation between temperature and kinetic energy. The relation between temperature and kinetic energy will be kinetic energy is directly proportional to temperature. So let us proceed towards the next topic where we will try to understand about specific heat. This is very important. What is specific heat? What is specific heat? We already have a formula. First I will explain the formula, then it will be easy for us to understand what is specific heat. What is the formula for measuring quantity of heat lost or gained? The formula for finding quantity of heat lost or gained will be Q is equal to ms delta T. At that time I told you what is S stands for. S stands for specific heat. So what is the formula for specific heat? From this formula we can derive the formula for specific heat. You send this M and delta T to the denominator. Send this M and delta T to the denominator. We'll get Q by M delta T. This is the formula for specific heat. So what is specific heat? Still we do not understood. Let us try to understand specific heat by using this formula. What is the formula says? S is equal to Q by M delta T. What is Q? Q stands for quantity of heat. M stands for mass of the substance. Delta T stands for difference in the temperature. So let us try to write the definition of specific heat first. Specific heat is nothing but amount of heat required to rise the temperature of amount of heat required to rise the temperature of unit mass of any substance, unit mass of any substance. Amount of heat required to rise the temperature of unit mass of any substance by 1 degree Celsius. 1 degree Celsius. That is actually called as specific heat. So what is this specific heat actually? I'll explain you with one example. Suppose if I have given you one answer to read, there are so many students in our classroom. Let us say 30 students are there. I have given them a small work that they need to read this definition. So every student can able to read the definition in a same time? No. Some children may read the definition within 1 second or 5 seconds or 10 seconds, or some people require more time, 1 minute, 2 minutes, 5 minutes, 10 minutes, whatever it may be. So that means we have different ability to grasp that answer in the same way. Different substance have different ability to receive heat or to deliver heat. To receive or to deliver. All substance do not receive heat in the same way, or all the substance do not release the heat in a same manner. Why, sir? Because of specific heat. Now let us say I am having two liquids. One is water, other one is coconut oil. Is that clear? One is water, other one is oil. Sir, how much amount of water I am having? Let us say I am having 1 gram of water. 1 gram of water. Every body will have its normal temperature. What is my normal temperature? 37 degrees Celsius. What is the temperature of water? Let us say the temperature of water right now the temperature of water is 25 degrees Celsius. Now I heated this water and its temperature has increased from 25 to 26 degrees Celsius. 25 to 26 degrees Celsius. Now can you tell me how much difference in the temperature is? The difference in the temperature is 1 degree Celsius. To increase and to bring that 1 degree Celsius difference, I need to supply heat. I need to supply heat. That heat is called as specific heat. What is specific heat? Q. Formula says Q. What is Q stands for? Amount of heat or quantity of heat. Anything you can say. Amount of heat or quantity of heat required to rise. What is the temperature of water? 25. How much you want to increase the temperature of water? 1 degree Celsius. How much heat is required? That heat is nothing but specific heat. So what is the specific heat? Amount of heat required to rise the temperature of unit mass. In physics, 1 kg, 1 gram, anything related to 1, that is called as unit. Unit mass. Unit mass of substance. Unit mass of any substance by 1 degree Celsius. On the other hand, I am having oil. Oil is also having some temperature. Let us say the temperature of oil right now is 23 degrees Celsius. I increased its temperature by 25. Again, there is an increase in temperature is how much? 1 degree. But here heat required is different. Here heat required is different. Because this is water, that is oil. In both cases, heat required is not same. So that difference is known as specific heat. So I hope everyone understood what is specific heat and its formula. Let us see its units. Even specific heat. Today we are studying 3 measurable quantities. Heat we measured, temperature we measured, and we also measured what? Specific heat. What is the formula for specific heat? S is equal to Q by M delta T. So let us see its units. Specific heat units. Units of specific heat. Units of specific heat. Again, we need to measure in CGS as well as in SI. What is the formula? S is equal to Q by M delta T. Let us see its CGS unit. Q is measured in what? Calories. M is measured in what? Grams. Temperature is measured in what? Celsius. Short form we can also write cal gram degree Celsius. This can also be written in this way. Cal gram inverse Celsius inverse. So this is the CGS unit. What is the SI unit? How heat is measured? Joule per kilogram Kelvin. This can also be written joule kilogram inverse Kelvin inverse. So these are the units for measuring specific heat in CGS system as well as in SI system. We also need to remember this relation also. Let us see what is the relation. One cal per gram degree Celsius is equal to 4.186 into 10 to the power of 3 joule per kilogram Kelvin. This is the relation between cal per gram degree Celsius and joule per kilogram Kelvin. Is that clear? Cal per gram degree Celsius, joule per kilogram Kelvin is the relationship between cal per gram degree Celsius and joule per kilogram Kelvin. Still there are some answers. In 10th standard there is a one most important derivation lab activity, how to find specific heat of a lead shot. So you don't require that entire lab activity, but you need to remember its formula. Specific heat of solid SL is equal to M1SC M1SC plus M2 minus M1, M2 minus M1 SW, bracket close, T3 minus T1, T3 minus T1 by entire by M3 minus M2, bracket close, M3 minus M2, T2 minus T3 will be the formula to find out specific heat of a solid substance, lead shot particularly. So this is a 10th standard derivation for 8 marks in your SSC exams, most important, but we don't require to read the derivation. We need to only keep this formula in our brain. M1SC plus M2 minus M1SW, specific heat of water, T3 minus T1 by M3 minus M2, T2 minus T1.